Hello, I'm Collin Keegan, and this is my application for the WPI Design Innovation Scholarship. I'm Programming Team Lead on FTC Team 18438, and I've made some really cool things this year. The major project I've worked on is auto-aim and inverse kinematics. This year, because we have to score on these thin yellow poles, it's sometimes hard for our drivers to aim when they're all the way on the other side of the field. To account for this, I created a computer vision-based automatic aiming system that uses inverse kinematics and a camera to automatically aim the robot as long as we're in approximately the right place. This idea started when me and a few friends realized that looking through the cone with a camera was a really good way to detect which direction the junction was in. After the obligatory first try that didn't work, we made a version that, while very rough, was an incredibly effective proof of concept. It showed that the idea of using the camera to align the robot precisely to the junction worked really well. Putting this idea onto our fully assembled robot definitely improved our scoring, but we still weren't quite happy with how fast it was aligning, because moving the entire robot meant there was a lot of inertia for the PID controller to adequately deal with. We realized, however, that because our robot had a pivoting arm on the end of slides, we could use an inverse kinematic system to precisely coordinate them, extending the endpoint out without actually changing the height it was at, and we could do this very precisely. On top of the math for inverse kinematics, though, we also had to change our auto-aim system to actually give the distance in units, which meant a few dozen more Desmos graphs to change the auto-aim math. However, once it worked, it was pretty spectacular.
Look at that!
Wow! Oh my god, it's so pretty!
That's like half second, right?
And it's gonna get better, because look at how untuned that is.
That's crazy.
So that's gonna be even better. I mean, the PID can get a lot. I'm gonna just, yep, I like you, Gyro, there we go.
That is amazing!
The next major update to auto-aim came when our mechanical team realized that we could tip cones to use them to automatically align themselves. Combining this with auto-aim gave us incredibly fast, incredibly reliable automatic aiming. One of the great things about our team is that because our mechanical team knows coding, and because even I know how to CAD parts for the robot, we can work together really closely and really effectively. Of course, there's always some room for improvement with any system that you think is 100% reliable. Over winter break, we added a turret to our arm, which made my job of doing the math a little bit harder, but it did mean that we now had essentially full 3D control of the endpoint of the arm, so we could move it to arbitrary positions in an XY plane at the height of the junction. This also is a program that lets me do kind of cool things with the robot, like the demo you saw at the beginning of the video where the robot draws the WPI logo in the middle of the air. Even though we're still working on it, the early versions of our 2D auto-aim system have been incredibly useful. After a quick break from programming to write this all up for judging, I traveled with my team to Chesapeake where we competed in their regional championship, scoring some incredibly high-scoring autos reliably thanks to auto-aim and also just having a blast. And we won, so we're going to be going to Worlds again this year, which is super exciting. Apart from auto-aim, I've worked on a ton of cool things this season, from oscilloscope diagnosis of servo issues to assisted movement in teleop. I've done a lot of really cool things in my time at FTC, and it's just been really fun, but auto-aim is definitely the biggest project that I've worked on so far. It's also just been incredible to see something like this go from imagination and theoretical math to just building it. My favorite nights at the workshop are when we take something that is theoretically possible, but is really just an idea we have, and actually bringing it into real life. Seeing a moving robot actually doing what you want it to do is just so cool to me, that you can make something from your imagination to a real thing so quickly. And so I just love FIRST so much for that aspect. And it's been amazing being on teams for the now 6 years I've been in the program. I've emceed for FIRST events, I've volunteered with various outreach efforts my team has done, going to local schools and teaching the next generation about STEM, and overall, FIRST has given me so much. And I'm both proud of the things I've created for our robot, but even more than that, I'm proud of overall what the program has done for me and what I've done for it.